So we've been talking in a lot of general terms. How to design test suites, black box testing, glass box testing, how to think about bugs and how to think about trying to find bugs using unit testing and integration testing. But let's do an example. Let's talk about, and let's actually walk through a piece of code to look at how we can think about actually doing debugging. And the basic idea behind good debugging is to think about it as if it was a search problem. I've got some incorrect behavior in my code. I'd like to find an explanation, because if I can explain why it's wrong, that'll help me figure out what to do to fix it. So, just like a good scientist, how should you do this? Well, first, study the available data. Look at both the correct test cases and the incorrect ones. Looking at those will help us try and figure out what might be an explanation. How can I form an hypothesis that's consistent with the data, that would say it should work on these cases, but would explain why it might be failing on the cases where it fails. Once I've got an hypothesis, I can then design and run a repeatable experiment with the potential, in particular, to refute the hypothesis. That is, when I build now that example, once I've got an hypothesis, I can design an experiment. If I do the following, if the result is this, it'll tell me something about where the bug might be. If the result is that, it'll tell me something else. So that experiment should have the ability to either reinforce or refute the hypothesis about where the data, where the code is going wrong. And of course, I want to keep records of this. I want to go through all of the things I've done inside of the experiment, because that information is going to help me narrow the range of the hypotheses about what might be wrong inside of my code. Okay, with that, then what does it mean to say treat debugging as if it's search? Well, what we want to do is take the space of possible errors and keep narrowing it down. And so we'd like to design things that help us expose intermediate stages of the computation. In other words, if I said I think there's a bug in this piece of code, I'd like to be able to narrow down where in the code that bug could be happening. And a really nice way to do that is to use a very simple tool, a print statement. I'm going to use an example of putting in print statements in intermediate spots in the code to help me see what is the state of the computation at that point. And the idea is I'm going to identify places in the code where I have an expectation of what the values of variables should be inside of the code. And I'm going to use that information, the difference between what I see in the print statement and what I expect there, to help me narrow down the space of possible places where the bug actually lies. And a good way to do this is to use that notion of bisection search or binary search that we've talked about before, to use information to reduce the range of places where the bug could be in a very natural way. All right, let's look at an example. This is a simple little example, but we're going to use it. This is a piece of code that's going to try and check whether something's a palindrome. And so my function up here is pal. It's got something that says I'm going to take a list as input, and then what am I going to do? I'm going to make a copy of the list. I'm going to reverse that copy, and then right here, if the reverse copy and the original one are the same, then it's a palindrome, because I took a list, I flipped it, and then I'm basically saying, let me compare the flipped version with the real version to try and decide if it's the same or not. I'll build a little input function here. I call it silly because it's a silly piece of code that says, I'll give it a number, and then I'll have the user type in a set of characters to create that list. And once I've got that, I'll simply pass it on to isPal to check to see, is it actually a palindrome or not. Simple piece of code. It's buggy. I know it's buggy. That's deliberate. But let's look at what happens if we were actually to run this. So let's actually run this code, and if I go over to my environment here, I'm going to load up this code, and I'm going to type in silly, and I'll start off with 5. So I'm going to give it A, B, C, B, A, and it says, oh, that sequence is in fact a palindrome. That's nice. Let's give it a longer number, a longer example. E-A-L-I-N-N-I-L-A-P. And that also is a palindrome. Sounds good. Sounds like I got good code. Let's try a simple example. And we'll give it A and then B. Oh dear. It says that the sequence AB is a palindrome, and clearly it's not, because AB is not equal to BA, which would be the thing going back the other direction. Okay, so I got a bug. I could use binary search now to try and isolate where that bug is in the code. And one of the good things to do here, by the way, is even though I might have a bug with a really long sequence, I happen to do it with a simple one, I'm always better off starting with simple examples to try and identify where the code is. So I'm going to try and debug this just using the input of AB. Okay, so I've got a bug here. What am I going to do? Well, I'm going to pick a spot about halfway through the code, halfway into the code. There's that binary idea. And I'm going to devise an experiment. In particular, I'm going to pick that spot where it's easy to examine intermediate values, and I'm going to put in a print statement. So, if I look inside of silly, there's the whole code for silly. And right here, that's about halfway through the code, I'm going to put in a print statement there. And the print statement is going to say, I'm going to print out what is the value of result at this stage. Remember, silly is building up a list of inputs that it's going to pass on. So I'm going to actually ask at this stage, what's the value of result? Okay, so let me go back over to my code. And I've actually done that. I've got another version of the code. It's got that print statement right there. So let me now load up this piece of it. And I'm again going to type in silly of 2. And I'm going to give it A and B. It prints out just the list B. But if you think about this, I would have expected that the result should be the list of A and B. I typed in A and then I typed in B. So this is already telling me something. I ran the code, I just got B. I should have had the value or the list of A and B. What does it tell me? Because I'm using binary search, I know that there's at least one bug, there may be more, but there's at least one bug prior to that spot in that print statement. Because when I get to that point, I've got a value that's incorrect. So that's nice. It says, I now know that there's a bug there somewhere, and so I ought to be able to add in another print statement. And I'm going to do that. Let me go back to my code. In fact, let's just look at the code here. I'm going to stick another print statement that is going to be inside of the loop. And let's see what happens if I do this one. So I was printing after I'd gotten through it. Let's move it up inside of the loop and do the same thing. So if I go to my code here, now I got a version of it. And notice, it may not be obvious, I've just moved the print statement to inside of the loop. So in here it's going to print things out. That'll tell me as I run through the loop what's happening. And let's evaluate that. And if I type silly of 2, and I type in A, it prints out A, and I type in B, it prints out Okay. So this is now showing me that I'm getting the inputs, but I'm losing them. Because the first time through the loop I did have the list of the element A. But the second time through the loop, somehow A had gone away and I got the element B. And what's that telling me? Well, in fact, it suggests that I'm not keeping all of the elements. And if I go back to my code, I can realize that I've got a standard bug, which is that if I in fact look at my code, and I'm going to move to that code now, if I look at my code, notice that what's happening here, that right here I'm doing the initialization, or rather I should have said in the previous version of the code, I was doing the initialization of the result inside of the code. I can see that over here on my screen, right? Right here, I'm doing an initialization of result every time through the loop. I need to pull that outside of the loop. And so that's in fact what my code does here. I'm taking the result portion and I'm moving it outside the loop. That makes a lot of sense. I'm not going to keep reinitializing the list every time through. I want to initialize it once and then collect all of the pieces. So if I make that change, I'm going to make that change here. I now move that outside of here. Let's do another run of this. And if I type silly of 2, oops, sorry, I wanted of 2. I get A and it's got the list A and I get the A and B. Aha! So this is now good. It says I've at least fixed that portion, but it still says that the list of A and B is a palindrome. Okay, so we're getting somewhere. It says we're getting the data structure now properly set up, but we still have a bug somewhere. And that's a good reminder. Just fixing one bug doesn't say there aren't more bugs in the code somewhere. I've always got to make sure that I test everything. So I'm at least now getting the right pieces in, but I've still got a bug. And what do I know? It says that the second bug must lie somewhere below that print statement, right? I'm printing the value that's coming out after I have done the work. It says it's got to be somewhere else, so where could it be? Well, it's probably inside of isPal, because once I've set up the list properly, what am I doing? I'm checking isPal on that list. So let's again do the same thing. Let's pick a point in the middle of the code, isPal, and let's add a print statement there. So if I do that, I'm going to go up, and I'm going to remove my print statements from the other portions, and I'm going to pick a point roughly halfway through isPal, right here. And what do I want to do? Well, let me remind you, I said my idea of this test here is I want to look at what's the values of variables and how might I expect, or rather, what might I expect them to look like. So this print statement is going to print out both the value of temp and the value of x. My expectation is that this point, x is a list that I've passed in. Temp should be a reversed version of it, so they should have opposite order. Okay, let's try that. So I'm going to go over to my next version here. I've removed the earlier print statements and I've got that version. Let's call this one. And again, I call silly of 2. And I give it A and I give it B. So what did I do? I remind you, I said I'm going to now print out the value of temp, which should be a reversed version of the input list, and the value of the list. And you can see that that's not the case. They're not reversed from one another. Okay, so that says I must have some problem here, okay? Well, obviously I got a problem, it's not doing the right thing. And what does it say? I would have expected that x would be AB and temp would be BA, but they're not, they're the same. So what do I know? I know by binary search that the error must be happening somewhere prior to this print statement. By the time I get to this point, I've got a problem. So let's add in another print statement. And in particular, let's just add it in earlier in the code. So here, I'm going to put another print statement, this one right here, immediately be above the reverse. Now I should be able to see, I've isolated, if you like, where the code might be. Let's see what happens if I do that. So I've got another version of the code over here. I've got those two print statements. Let me run this one. I will type silly again of 2. I will give it A and B. Now I get two print statements out, and notice they're giving me the same thing. And this tells me something very nice. It says that somehow the reverse call is not doing the right thing, right? It says I've printed here, I've printed there. In both cases, temp and x are exactly the same, and yet temp should have been reversed by that call. So that says that must be where the bug is. And in fact, if you look at the code, you realize, yeah, I was a little brain damaged. I forgot to actually invoke the method. I simply access the method, but I need temp or reverse and call it. Okay, that's an easy thing to fix, so let's go make that change. And I can do that. We're going to make that change right here. And now there's that change. I've made that change there. Let's actually call it. So if I go back to my machine and I run it, I'm going to do a run of that. And I do silly of 2. And I give it A and B. Something funky happened. Right? On the first call, where I print out both temp and x after I've passed them in, they both have the form of A and B. After the reverse, temp is reversed, but oh my goodness, so is x. Right? They're now both in the form B and A. What's going on here? Well, we now have still narrowed it down that somehow the bug has to be in that line where I'm doing the reverse. Because beforehand, they're in the right form. Afterwards, temp got reversed, but so did x. And that's a hint. That says I've got an aliasing bug. We've seen those before with lists. That says when I reverse one, I've got another name that's referring to the same thing, and that's causing that to get reversed as well. And we know how to fix that. That's obvious. I don't want to just have x point, or temp rather, point to the value of x. I want it to point to a copy of x. So I will explicitly make a copy and then test it. So if I make that change, I'm going to make the change right there, and I actually test it, now when I run this, I can ask for silly of 2, I give it A and B, And oh, nice. Now you see beforehand, temp and A both have the same form. After the reverse, that second print statement says that temp is reversed, but B is staying the same. And now when I compare a reverse list or a copy of a reverse list in the list itself, I can see that it gives me the correct answer. This is not a palindrome, and I've said the right thing. Okay, so this says I've got the right version of things. I should now actually go back and check silly on my earlier things. So in fact, let's do a simple example. I should really remove the test, but let's do silly with A, B, C, B, A. And there you can see that in fact it prints out a reverse version of it in the version, it gets the right answer. And I could go back and do the rest of my testing to make sure that I'm in fact getting out the things that I want to do. What you've seen here though is a nice example of using search to narrow down where in the code the bug might be. And that search is using prints to identify variables and their values so that I can compare what I would expect with what I actually see to identify the places where there is bug. Let's now step back just for a second to talk about, so how might you think about debugging more generally? These tools are going to be really handy. But even then, it may still be hard to spot places where there are errors. And so let me highlight for you just some general pragmatic hints. First one is just look for the usual suspects. There are standard kinds of things where one makes an error. Do I have a boundary condition case? Am I passing in the wrong argument? Am I reversing the order of arguments? Have I forgot to call a method? Actually invoke it rather than just accessing it. So they put together a list of standard places and look for those just to check them. If you're really stuck with finding where the bug is, don't ask why the code's not doing what you want. Ask why the code is doing the thing it should be doing. Focus on what the code is doing rather than trying to spot where's the error. Changing the way you think about things may help out as you try and deal with this. Remember that the bug is probably not where you think it is. Or another way of saying it is eliminate locations where the bug might be. And in fact, that's what we just did here. That binary search was eliminating whole portions of the code where the bug could not be, or rather identifying places in the code where the bug could be. If you're really stuck, try and explain the problem. Talk to a friend and explain to them what you think the problem is. That elucidation of the problem often helps you identify where the bug may lie. Another big thing to do is not to believe the documentation. That's sort of a terrible thing to say, but a very easy way to get sidetracked into debugging is to look at the documentation or specification, assume that it's correct, and therefore assume that the code is doing something that it should be doing when in fact it's not. So sometimes the documentation is wrong and you want to deal with it. And of course, if you're really stuck, take a break, take a walk, and come back to it later. Now, these are very simple guidelines for debugging, and we've shown you a very simple method for doing some debugging. Debugging is an art, and you'll get better and better at it as you do more and more examples of it. But remember, that idea of trying to identify where the bug might lie, using glass box and black box testing to design a test suite, first to show that there is a bug, and then using the code itself to identify where the bug might be, these are going to be really handy tools for you.